Welcome to one and all. Today we are going to discuss a new chapter, Introduction to Trigonometry. There is perhaps nothing which so occupy the middle position of mathematics as trigonometry. You have already studied about triangle and in particular right triangles in your earlier classes. Let's take some example from our surrounding where the right triangles can be imagined to be formed. Suppose you are standing in front of a tall building like Burj Khalifa and you are looking to the top of the building. A right triangle can be imagined to be made. Is there any way to find out height of this building? Similarly, suppose a girl is sitting on the balcony of her house located on the bank of a river and she is looking down at a bowl placed on the stair of temple situated nearby on the other bank of the river. A right triangle is imagined to be made in this situation. In all the situation given, the distance or height can be found by using some mathematical techniques which come under a branch of mathematics called trigonometry. The word trigonometry is derived from the Greek words tri, meaning three, gon, meaning sides, and the metron, meaning measure. In fact, the trigonometry is the study of relationship between the sides and the angles of a triangle. Astronomers are used it to find out the distance of the stars and planets from the earth. Even today, the most of technologically advanced methods used in engineering and physical science are based on trigonometrical concept. In this chapter, we will study some ratios of the sides of a right triangle with respect to its acute angle called trigonometric ratios of the angle. We will restrict our discussion to acute angles only. Also, we will calculate the trigonometric ratios for some specific angles and establish some identities involving these ratios called trigonometric identities. In trigonometry, we will consider the right triangles only. So, consider a right triangle. Right triangle meaning you know what is that? One angle should be 90 degree so that the remaining two angles should be less than 90 degree. So, let us take one of the angle as a theta. Theta is a Greek symbol, Greek letter to represent the unknown's angles. So, let us take one of the angle A as theta. With respect to angle A, the side AB is adjacent side and the side BC is opposite side, and for this triangle AC is the hypotenuse. Similarly, suppose if you are taking angle C as theta, the side AB is opposite side and the side BC is adjacent side and AC it is hypotenuse. There is no change for hypotenuse since hypotenuse is the longest side or the side opposite to right angle. Mainly, there are 6 trigonometric ratios: sine, cos, tan, cosec, sec, and cot. Let's define what are the trigonometric ratios. First, we can discuss sine. Sine is defined as opposite side by hypotenuse. Here we are considering the angle A. So sine A is equal to opposite side by hypotenuse and cos is equal to adjacent side by hypotenuse and tan is equal to opposite side by adjacent side. If you know the first 3 trigonometric ratio, you can easily write the remaining 3 because the next one is cosec. Actually, the cosec is the reciprocal of sine, that is hypotenuse by opposite side. Similarly, sec is the reciprocal of cos. Therefore, it is equal to hypotenuse by adjacent side. And cot is the reciprocal of tan, that is meaning adjacent side by opposite side. That's all. Once again, Sine opposite side by hypotenuse. Cos adjacent side by hypotenuse. And tan opposite side by adjacent side. Cosec hypotenuse by opposite side. Sec hypotenuse by adjacent side. And cot adjacent side by opposite side. So, the trigonometric ratios of an acute angle in a right triangle express the relationship between the angle and the length of its sides.